Aston Martin has scored only 1 point, suffered 10 retirements, and fallen to last place, yet its biggest gamble may still be ahead. Adrian Newey's radical B-Spec removes weight from the chassis and gearbox, introduces a new nose, revises major aerodynamic surfaces, and changes the rear suspension. The forward chassis even required fresh crash testing before Hungary. But here is the shocking truth. The source does not confirm that this upgrade caused a suspension failure. What it does confirm is that the original AMR26 was so deeply compromised, Aston Martin had to perform major structural surgery just to save the project. And if this new car still fails, the problem may not be one component. It may be the entire team around Newey. Subscribe to the channel. To understand why Aston Martin reached this point, you have to go back to the mistake that poisoned the entire project before the car had even completed a serious lap. The problem was not one bad race. It was not one weak upgrade. It was not one unreliable component. Aston Martin began the new era already behind. Adrian Newey revealed that serious work on the 2026 car did not begin until the middle of March in 2025. The wind tunnel model did not arrive until the middle of April. By then, rival teams had already spent months developing their own cars under the new regulations. That delay was enormous. In Formula One, development does not happen in separate pieces. Every decision affects the next one. The chassis determines how the power unit fits. The power unit influences cooling. Cooling influences the shape of the side pods. The side pods influence how air reaches the floor. The floor influences how much grip the car creates. The suspension determines whether that aerodynamic grip remains stable when the car moves. So when the first major decision arrives late, the next decision becomes rushed. Then the next. Then the next. Very quickly, the whole car becomes a chain of compromises. Imagine starting construction on a house after everyone else has already completed the foundations. You may have better materials. You may have a brilliant architect. You may have more money. But while you are still deciding where the walls should go, everyone else is already working on the roof. That was Aston Martin's position. And the consequences appeared in one of the most damaging areas possible. Weight. Newey admitted the AMR26 chassis was a long way overweight. That phrase sounds simple. Its effect is everywhere. An overweight car accelerates more slowly. It requires more energy to brake. It changes direction with greater difficulty. It places more stress on the tires. It gives the engineers less freedom to position ballast where it can improve balance. And most importantly, the driver carries that disadvantage through every corner of every lap. Think of running while wearing a heavy backpack. You may be strong. You may know the route perfectly. You may even begin at the same speed as everyone around you. But the extra weight punishes every movement. Braking, turning, accelerating, recovering. The disadvantage never leaves. That was the AMR26. But the weight did not come from one isolated mistake. Part of it was linked to vibration problems created during the integration of Honda's new power unit. Part of it came from Aston Martin not having enough time to optimize the car properly. When engineers are rushed, they cannot explore every lighter solution. They protect the structure. They add material. They make components stronger than necessary because reliability must come first. That may prevent immediate failure. But it creates a performance penalty that remains trapped inside the car. Newey described the process with brutal honesty. When a car is designed in a rush, weight is one of the first things that suffers. That statement connected everything. The late start, the rushed design, the heavy chassis, the difficult power unit integration, the lack of proper testing. Aston Martin did not begin the season with one problem. It began with several problems feeding each other. Vibration could force the team to reinforce a structure. Reinforcement could add weight. Extra weight could hurt braking and direction changes. Poor direction changes could overwork the tires. Overworked tires could make the aerodynamics look worse. Then the engineers would struggle to identify where the real problem began. That is when development becomes dangerous. The team makes one change. Another area becomes weaker. It tries to fix that weakness. A third problem appears. It is like trying to level a table with 4 uneven legs. Adjust one corner, and another starts moving. That is why the B-Spec package matters. Aston Martin was not simply adding a little more downforce. It was trying to break the chain of compromises. The main chassis and gearbox architecture remained fundamentally unchanged. But Aston Martin removed weight from both. That alone was a serious intervention. The team also developed a new nose. It substantially revised the aerodynamic surfaces. It slightly revised the rear suspension. And because weight had been removed from the forward chassis structure, the car required fresh homologation and crash testing. That does not mean the original car was illegal. It does not mean the Formula One governing body opened an investigation. It was a standard safety requirement. But teams do not repeat structural approval work for a tiny adjustment. They do it because something important has changed underneath. That is the first real clue. The B-Spec was not cosmetic. It was structural. Aston Martin had reached the point where the original package could no longer be protected. The team had to go deeper. And the new nose may reveal the scale of the rethink. The nose is one of the first major areas to meet the airflow. What happens there affects everything behind it. The air moves around the suspension. It travels beneath the floor. It interacts with the side pods. It reaches the rear of the car. Change the beginning of that journey, and the entire car can behave differently. Imagine pouring water into a network of narrow channels. Change the shape of the entrance, and the flow through every later section changes. That is why a new nose can influence far more than the front of the car. It can change how the front tires respond. It can alter how the floor receives air. It can affect how stable the rear becomes. It can even change how sensitive the car feels when it brakes, turns, or rides over a curb. The aerodynamic surfaces were also substantially revised. That wording matters. Aston Martin did not describe a small adjustment. It described a major change. That suggests the team was not simply trying to improve the original idea. It was trying to make the original idea work at all. Because the first version of the car attracted attention. Its nose looked aggressive. Its side pods appeared ambitious. Its floor design created discussion. But visual drama means nothing if the car cannot transform those ideas into lap time. Formula One is full of concepts that looked intelligent and failed on the circuit. A design can create strong downforce in one perfect condition. Then the car moves. The front drops under braking. The rear rises. The tires deform. The floor approaches the track. The airflow changes. And the grip disappears. That is the difference between theoretical performance and usable performance. Theoretical performance exists in the computer. Usable performance survives the real world. Braking, turning, acceleration, curbs, wind, fuel changes, tire wear. The best Formula One cars do not only produce high downforce. They produce downforce the driver can trust. Aston Martin's original car did not appear to offer that trust consistently. And the slight rear suspension revision may have been designed to attack exactly that kind of weakness. The suspension does far more than connect the wheels to the chassis. It controls movement. When the driver brakes, the weight moves forward. When he accelerates, it moves backward. When he turns, the load transfers from one side to the other. The suspension manages how quickly those movements happen. It also helps keep the floor inside the correct operating window. That is critical. If the rear of the car moves too much, the airflow underneath can become unstable. The driver may feel grip in one corner, then lose it in the next. The car becomes unpredictable. And unpredictability destroys confidence. A revised rear suspension could help Aston Martin control the aerodynamic platform more effectively. It could improve stability under braking. It could help the rear remain calmer under acceleration. It could allow the new floor and aerodynamic surfaces to perform more consistently. But every suspension change creates risk. Make the rear too stable, and the car may refuse to rotate. Give it more freedom, and the rear may become nervous. Make the setup too stiff, and the car may struggle over bumps and curbs. Make it too soft, and the floor may move outside its ideal window. The goal is not maximum stiffness. The goal is control. And that is what this entire B-Spec package appears designed to create. Control over mass. Control over movement. Control over airflow. Control over the relationship between the front and rear of the car. That is why the upgrade became so important. Aston Martin was not trying to find one fast lap. It was trying to create a car that behaved like one complete machine. But the pressure surrounding that attempt was already enormous. Pre-season testing in Bahrain and Barcelona had been dominated by power unit integration problems. Instead of completing a normal program, Aston Martin spent valuable time dealing with failures and limited running. The team did not gather the understanding it needed. Newey later described the opening Australian Grand Prix as the wake-up call. That race was effectively the team's first meaningful on-track test after a chaotic pre-season. Think about what that means. A new car. A new Honda partnership. A new technical era. And almost no reliable preparation. The championship began before Aston Martin truly understood what it had built. Then the results made the situation even worse. 1 point all season. 10 retirements. Last place in the Constructors' Championship. That is not simply a lack of speed. It is a failure to create a dependable racing program. And the Belgian Grand Prix exposed the gap in brutal fashion. Kimi Antonelli won for Mercedes. Charles Leclerc finished second for Ferrari. Max Verstappen completed the podium for Red Bull. Fernando Alonso finished 19th, 2 laps behind. Lance Stroll retired after 25 laps because of another problem with the AMR26. The leaders were fighting for victory. Aston Martin was fighting to complete the race. That was the reality immediately before Hungary. And that is why the B-Spec package carried so much expectation. People began spreading claims that it could be worth 2.5 seconds. That number was never confirmed by Aston Martin. Newey did not confirm it. No official result proved it. Newey only said the team expected a large step. Then he refused to attach an exact number. That caution was important. Because he understood the difference between prediction and proof. The wind tunnel can predict improvement. Simulation can suggest more grip. Engineers can calculate the effect of reduced weight. But the circuit decides what is real. The tires decide. The curbs decide. Reliability decides. And the drivers decide whether the car finally feels connected. That last point may matter more than anything. Fernando Alonso wants tangible progress. Not another promise. Not another presentation. Not another explanation about what the car could become. He wants something he can feel. A front end that responds. A rear that remains stable. A car that changes direction without fighting him. A platform that allows him to attack instead of protect. Newey acknowledged how important this package could be to Alonso's future. If the car improves, Aston Martin hopes Alonso will remain for another season. But Alonso wants clear evidence. That means the B-Spec is not only being judged by the stopwatch. It is being judged by a 2-time world champion deciding whether the project still deserves his belief. And Hungary is a ruthless place to test that belief. The Hungaroring rewards balance. It rewards aerodynamic grip. It rewards confidence. One corner flows into another. There are few long straights where raw power can hide a weak chassis. A heavy car struggles to change direction. An unstable rear forces hesitation. A weak front creates extra steering. An inconsistent floor makes grip appear and disappear. Every weakness follows the driver through the lap. That makes Hungary the perfect test for Newey's changes. If the lighter structure works, the car should feel more agile. If the new nose improves the airflow, the front should respond more naturally. If the revised surfaces create more stable downforce, the drivers should feel a wider performance window. If the rear suspension revision controls the platform, the car should become more predictable under braking and acceleration. But those are expectations, not confirmed results. And this is where the danger becomes enormous. A package this large can create a faster car. It can also create a car the team does not understand. The preferred ride height may change. The correct wing level may change. The suspension settings may need to be relearned. The tire behavior may shift. The balance may evolve differently as fuel burns away. Aston Martin could bring a better car to Hungary and still struggle to unlock it immediately. The old setup knowledge may no longer apply. A setting that worked before may now hold the car back. A front wing level that balanced the old nose may overload the new one. A rear setup that protected the tires may prevent the new floor from working properly. That creates another race against time. The package must not only be fast. The team must understand why it is fast. That is the difference between one dramatic lap and a real development direction. One lap can be luck. A real direction can be repeated, improved, built upon. Aston Martin desperately needs the second one. Because after 1 point and 10 retirements, the team cannot afford another illusion. It needs a car that finishes. A car the drivers trust. A car the engineers understand. And a car that proves Adrian Newey's ideas can survive the organization around him. That may be the deepest question of all. People see Newey's name and expect instant success. They remember Williams, McLaren, Red Bull. They remember championships. But Newey does not build a car alone. Hundreds of people must turn the concept into reality. The parts must be manufactured correctly. The Honda integration must work. The simulation must match the track. The mechanics must assemble the car accurately. The engineers must find the correct setup. The drivers must trust the result. One weak link can damage everything. An Aston Martin season suggests there may be several weak links. That is why some observers have asked the most uncomfortable question possible. Did Adrian Newey fail? Or did Aston Martin fail Adrian Newey? The B-Spec package may offer the first serious answer. If the car improves, Aston Martin can point to the late start, the rushed original design, and the difficult Honda integration. The new package would show that the project can recover when given time. But if the car remains slow and unreliable after changing this much, the problem may no longer be the concept. It may be the system responsible for creating it. And no new nose can fix a broken system. That is why this opening chapter matters. Aston Martin is not simply bringing another upgrade to Hungary. It is bringing a test of its entire future. A lighter chassis, a lighter gearbox, a new nose, substantially revised aerodynamics, a modified rear suspension, fresh crash testing. All of it created to correct a car that began months late and arrived deeply compromised. And now the next question becomes unavoidable. What happens when this radical new version finally reaches the limit? Does it reveal the performance Newey believes is hidden inside the project? Or does it expose a deeper weakness Aston Martin cannot solve with new parts alone?